when we get through practicing these, we look at the sets that we have here, and we're determining which set has the largest standard deviation. Well, I can calculate each one of them. We saw how we can kind of get through that on the previous problems. But another way to look at this is to just remind ourselves that the definition for a standard deviation is it's the average distance from the mean. Okay, and if we look and calculate the mean quickly, we'll find that these are symmetrical sets of data where the mean is actually 6. You got stuff that's above and below, but if you calculate the mean, x bar for both of these is equal to 6. Okay, well, set A has data points that are up to 3 units above and below, and 5 and 6 are directly above and below 6, so it's pretty confined. You look at set B, you've got, it goes from down to 2 as high as 10, and we can see that those compare, the minimums and the maximums are actually greater. So by those themselves, and the fact that 4 and 8 are further away than 5 and 7, all of this data is more spread out than that data there. They both surround the 6 in symmetrical ways, but these are further away. So the largest standard deviation is set B because the data is more spread out, blah, 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 your own words. Okay, you look at set at number 5. You've got a similar situation there. You've got another x bar when you calculate it is equal to 15. That's the mean. It's right in the center. Again, it's symmetrical. And you look at this and you say, whoa, 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 it doesn't look like there's a difference because you've got your 10s and your 20s. Your minimums are the same distance from 15 as well as your maximums. But if any points are different, 14 is only 1 below 15, 16 is only 1 above 15, but 11 and 19 are further away from 15 than these two here. Just these by themselves being 4 units away from 15, that's more than 1 unit away from 15 here. We could calculate the standard deviations, but if we're just trying to think our way through it in terms of what makes more sense, which has the larger average difference, that is the second set again, it's set D. Now this is tricky. You're inclined maybe to say that the second set here has larger something because they're all in the 80s and 90s, where all these are mostly single digits. But if you look closely, and we're talking about the average distance from the mean, okay, the mean of this one is in the neighborhood of 9, the mean of this one's in the neighborhood of 89. Okay, I think it's actually 8 for both of them, 8 and 88. Okay, the mean of this is 8. If you calculated a standard deviation, you have stuff that's 6 units below 8, 6 units above 8. Here, if you look at 88, you have 6 units below 8, 6 units above 8. Well, if x bar equals 8 for this and x bar equals 88 for this, just take a quick look at the differences. X minus 8 is a negative 6. 6 minus 8 is a negative 2, another negative 2. This is a positive 1, a positive 3, and a positive 6. Well, if I take 88 and take 82 and subtract that, I've got a negative 6. I've got a negative 2, a negative 2, a positive 1, a positive 3, and a positive 6. Without going any further, we can look and see that just the differences from this average compared to that average are exactly the same. So this is a bit of a trick question in that there is neither is larger. In fact, they have exactly the same standard deviation because the differences from the mean are exactly the same, even though these numbers are a lot bigger.